Assalamualaikum warahmatullahi wabarakatuh. Abdul Halim's here. In this video, we are going to talk about factor theorem. Now, let's talk about factors of number. For example, number 10. Okay, 10 can be written as 1 times 10 multiply. We have negative 1 multiplied by negative 10. We can also multiply 2 by 5. Also we get 10. Okay, we can also multiply negative 2 by negative 5. Also we get 10. Now all these numbers, that is positive negative 1, positive negative 2, positive negative 5, and positive negative 10 are all factors of 10. That is, if we divide 10 by any of these numbers, okay, we'll get the remainder equal to 0. Okay, now we can extend this idea into polynomial. Now suppose that we have this polynomial, that is Px equal to x squared plus 5x plus 6. Now this polynomial is equal to, okay, the product of x plus 2 and x plus 3. That is, if we expand the terms on the right hand side, okay, we are going to get this polynomial, that is x squared plus 5x plus 6. Thus we say that x plus 2 is a factor of Px. Now the same thing for x plus 3, that is x plus 3 is also a factor of Px. Now how can we convince ourselves that these are factors of x squared plus 5x plus 6? Yeah, we show it by division. That is, when we divide x squared plus 5x plus c by any of these factors, for example, we take x plus 2, okay, now we want to show that the remainder is equal to 0, because we claim that x plus 2 is a factor of x squared plus 5x plus 6. Therefore, when it is divided by x plus 2, the remainder must be 0. Now, let's show that the remainder is 0 by doing long division. Okay, let's do it over here. We have x squared plus 5x plus 6. We want to divide that by x plus 2. Now, to have x squared, we have to multiply x by also x. So we have x squared. Now 2 times x is 2x. We have to subtract in order to cancel x squared. So x squared minus x squared is 0. 5x minus 2x is 3x. Now we take down 6. Okay, and then we multiply by 3. Okay, to get 3x. And 2 times 3 is equal to 6. Now let's subtract this. So 3x minus 3x is 0. 6 minus 6 is also equal to 0. You see, now we have the remainder. Okay, the remainder is equal to 0. Okay, that shows that x plus 2 is a factor of x squared plus 5x plus 6. Now if we do the same thing, that is, if we do this division, that is x squared plus 5x plus 6, we divide it by x plus 3, okay, Since x plus 3 is a factor of x squared plus 5x plus 6, when we do long division, we're supposed to get the remainder also equal to 0. That's why we say x plus 3 and also x plus 2, they are all factors of x squared plus 5x plus 6. Alright, now the problem is, okay, now suppose that we are given a polynomial, okay, and we are asked to factorize that polynomial. Now the question is how, how to do that, how to factorize a polynomial, okay, and that's where factor theorems come into play. Now let's see what factor theorem says. It says this: if PC equal to 0, then x minus c is a factor of px. See this statement, PC, okay, that c come from this expression, that is x minus c. Okay, we use that value c, whatever that value is, and substitute into x, then we have PC, right? Now if we find out that PC is equal to 0, then we can conclude that x minus c is a factor of px. Okay, that's what factor theorem says. Okay, now let's look at this example number 1, okay, which says that given a polynomial px equal to 2x cubed minus 3x squared minus 5x plus 6. Now, is x minus 1 is a factor of px? Okay, that's the question we want to check, right? Whether x minus 1 is a factor of px. Now, let's do that by using factor theorem. Okay, what we have to do is we have to check PC. So we have, let's write down again px down here. Px equal to, we have 2x cubed minus 3x squared minus 5x plus 6. Okay, now let's find out what is PC. C in this case is equal to 1. So what is P1? Let's substitute x equal to 1. So 2 times 1 cubed minus 3 multiplied by 1 square minus 5 multiplied by 1 and then plus 6. This is equal to, we have 2 there, we have minus 3 here, and then minus 5 there, and then plus 6. And let's see what's the value that we get. 2 minus 3 is negative 1, negative 1, negative 5 is negative 6, negative 6, okay, plus 6 is equal to 0. Yeah, we have P1, we have exactly equal to 0. Now, what that says according to factor's theorem is that, okay, we can conclude, therefore, x minus 1 is a factor of whatever that polynomial is, that is 2x cubed minus 3x squared minus 5x plus 6. Now let's proceed to example number 2. We are asked to factorize this polynomial, that is px equal to x squared minus 4x plus 3. Maybe some people will just say that why not we just use our calculator to solve it, because it's much easier, much faster to do it, by using calculator. Yeah, you can use calculator to do it, but you'll not be thinking, because in the process of solving problems like this, it will involve a lot of concepts, ideas, and interconnection between all these concepts will make mathematics more interesting. So we are not going to use calculator here, of course. We are going to use factor theorems, So we are looking for PC, okay, in such a way that when we substitute x equal to c, we get 0. Okay, we are looking for this particular number c in such a way that when we substitute that value c into this polynomial, into the value of x, we get 0. So we are looking for that number. Alright, so that number is actually coming from the last, the last term from this polynomial, that is 3 there. So we better list down all factors of 3. All factors of 3. That is plus minus 1 and plus minus 3, right? So we are going to try, okay, this, what we call these numbers, these factors of 3 one by one, and see which one will get 0. Okay, which one will make PC equal to 0. So first let's try P1 equal to, substitute into Px, we have 1 square minus 4 times 1 also, then plus 3. So we have 1 minus 4, and then we plus 3. What you get? 1 minus 4 is negative 3, plus 3 is 0. Yeah, you get P1 equal to 0. Yes, P1 equal to 0. Therefore, we can conclude that x minus 1 is a factor of Px. Yes, we already found one of them. Now let's see the next number. After 1, let's see, maybe we want to try P of negative 1, for example. Now let's see, when x equal to negative 1, what will happen? Let's substitute it into Px. So negative 1 square minus 4 times negative 1, okay, plus 3. See what we get this time. So negative 1 square is 1. Negative 4 times negative 1 is positive 4. And then plus 3. Oh, this time we get 8. And this is not equal to 0. We are not interested in that. We are interested if we have, the value is equal to 0. Next, let's try, okay, the next number, that is P of 3. That is 3 square minus 4 times 3 plus 3. See what we got this time. Equal to 3 square is 9. This is 4 times 3 is 12. Now plus 3. 9 minus 12 is negative 3. Negative 3 plus 3. Yes, we have 0. Alright, so we get another factor of Px. That is, therefore, x minus 3 is a factor of Px. Alright, now from our solution here, we already get two factors of Px, right? That is x minus 1, and we have also x minus 3. Therefore, we write down, okay, our polynomial, that is Px, that is x square minus 4x plus 3, okay, having two factors, that is x minus 1 and, okay, x minus 3. You are ready for example number 3? Yeah, this is the question here. Okay, factorize the polynomial Px equal to x cubed plus x squared plus 2x plus 2. Alright, so we are looking for PC. We are looking for value of C such that PC is equal to 0. Okay, again, as in the previous example, okay, we are looking for this value of C. And that value of C coming from the factors of this number 2. That is plus minus 1 and plus minus 2. Okay, these are the numbers that we should try, okay, for the value of C, and substitute it into our Px and see whether we get PC equal to 0. First, let's try the value of positive 1. So let's try P1. Okay, substitute it into this polynomial. That is, we have, if x equal to 1, we have 1 cube plus 1 square plus 2 times 1 and then plus 2. So we have 1 plus 1 plus 2 plus 2. Oh, of course, this is not equal to 0. So we are not interested in that. Let's try the next number, that is negative 1. So substitute this time x equal to negative 1. See what happened. So we have negative 1 cube plus negative 1 square plus 2 times negative 1 plus 2. And see what we get this time. So this one is negative 1. We have plus 1 minus 2 and plus 2. You see, negative 1 plus 1 is 0. Negative 2 plus 2 is 0. Yes, we get 0, right? Yes, we are very happy. So, we conclude. This one is P negative 1. P negative 1 is equal to 0. Therefore, we conclude that x plus 1, okay, is a factor of Px. Okay. Now, to find other factors, okay, this time we do it by using long division. Alright, so let's do long division. That is, let's divide this polynomial, okay, by our first factor here, that is x plus 1. Okay, let's do long division. Let's do long division to find other factors. Right, that is, we want to divide our polynomial, that is x cubed plus x squared plus 2x plus 2. We are going to divide by our first factor that we just find out, that is x plus 1. So we want to divide our polynomial by this factor, that is x plus 1. Okay, so we have to multiply by x squared. So if we multiply that, we have x times x squared is x cubed. 1 times x squared is, we have x squared. So let's subtract. Okay, x cubed minus x cubed, 0. X squared minus x squared, also 0. We take down 2x plus 2. So to get 2x, we have to multiply x by 2. So 2 times x is 2x. 1 times 2 is 2. So we subtract. We also get 0. Right? Okay, therefore now, our long division process, the process of long division is already complete. Alright. And x squared plus 2, okay, is another factor. Therefore, okay, our Px, therefore, Px, that is equal to x cubed plus x squared plus 2x plus 2 is equal to x plus 1, okay, and multiply by this quotient here, x squared plus 2. Okay, multiply by x squared plus 2. Okay, are you ready for example number 4? Yeah, in this question we are asked to factorize this polynomial, that is Px equal to 6x to the power 5 minus 6x to the power 4 minus 9x cubed minus 3x squared minus 6x completely. So let's write down again Px down here. Px equal to, so we have 6x to the power 5 minus 6x to the power 4 minus 9x cubed minus 3x squared, and we have minus 6x. Now if look at the coefficient carefully, we have 6, 9 and 3. We notice that these numbers are multiple of 3, so we can take out 3 outside. And at the same time, okay, all terms here, they have x in it, so we can take the lowest degree of x, that is, we can take out x. Okay, so we factorize 3x outside, so we have 2x to the power 4 minus 2x cubed minus 3 times 3, 9, x squared. We have minus x here, and we have minus 2, like this. Okay, so that's what we have in this bracket. Okay, 2x to the power 4. We have, okay, minus 2x cubed minus 3x squared minus x and minus 2. Now let's call what we call the polynomial in this bracket. Okay, give it a new name. For example, q. Let's call that polynomial qx, right? Okay, now we are going to factorize qx some more. So we have, write down qx equal to 2x to the power 4 minus 2x cubed minus 3x squared minus x minus 2. Okay, we are trying to factorize q now. For the time being, we forget about px. Okay, we are coming back to px later on. Again, as I mentioned last time, we are looking for qc, okay, such that we want to have qc equal to 0. And this c, this number c, coming from the factors of this number, alright? That is positive negative 1 and positive negative 2. Okay, let's try these numbers and see whether we get qc equal to 0. Now let's try the first number, the simplest one, that is q1. Okay, what do we get? 2 times, this is 1, this is negative 2 times 1 also, negative 3 times 1 also, negative 1 minus 2. We get that one. So 2 minus 2 minus 3 minus 1 minus 2. Okay, and we don't get, it's not equal to 0. Okay, so x equal to 1 out, because we don't get the value of q1 equal to 0. Now let's try q negative 1. Q of negative 1. See what we get this time. Okay, what is the function? Oh, up there. Okay, so we have substitute x equal to negative 1. So 2 times, we have 1, we have negative 2, we have negative 1 cube is negative 1, we have negative 3 times 1, we have minus negative 1, and we have minus 2. Okay, let's simplify. What you get? Okay, we have 2, we have plus 2, we have minus 3, we have plus 1, we have minus 2. And see, 2 minus 2 is 4, 4 minus 3 is 1, 1 plus 1 is 2, 2 minus 2 is 0. Yes, yes, we get q negative 1, q of negative 1 is equal to 0. Therefore, we can conclude that x plus 1 is a factor of qx. Okay, now we have tried 1, we also have tried negative 1. How about positive 2 and negative 2? Let's try those, right? So let's try q of 2. Okay, where is our function again? We have 2, we have 2. Alright, 2 to the power 4 is 16. We have minus 2. 2 cube is 8. We have minus 3. 2 square is 4. And then minus 2. And then minus 2. See what we get. So we have 32 minus 16 minus 12 minus 2 minus 2. Let's check it out. So 32 minus 16 is 16. 16 minus 12 is 4. 4 minus 2 is 2. 2 minus 2 is 0. Yes, we get another one. that is q2 also equal to 0. Therefore, we can conclude that therefore x minus 2 is a factor of qx. Okay, so far we already got two factors for q, that is x plus 1 and x minus 2. Okay, so far we have x plus 1 and x minus 2. Now let's multiply these two factors of q together. So x times x, like this. X times x is x squared. X times negative 2 is negative 2x. 1 times x is positive x. And 1 times negative 2 is negative 2. So we have x squared minus x minus 2. Okay, and now what we are going to do next is we are going to divide qx by this, by x squared minus x minus 2. So that's what we are going to do now. That is, we are going to divide by using long division, of course. So that is 2x to the power 4, okay, minus 2x cubed minus 3x squared minus x, and then at the end minus 2. We are going to divide qx by x squared minus x minus 2, like this, and see what happened. So in order for us to get 2x to the power 4, we have to multiply by 2x squared there. So once we multiply 2x squared by this term here, we have 2x to the power 4 minus 2x cubed, and we have minus 4x squared. Now let's subtract this. We have 0 there. We have 0 also here. We have x squared. Okay, x squared, and then take down minus x and minus 2. You see what we have here? What we have here is the same as what we have here, right? So multiply by 1 in order to cancel everything. So we have x squared minus x minus 2. Subtract those. So the remainder is equal to 0. Okay. Therefore, now from this long division, we get another factor for qx, that is 2x. That is this one, that is the quotient 2x squared plus 1. Okay, therefore now we can write down qx. Qx is equal to, okay, we already got two of those, that is x plus 1. Okay, x plus 1 multiplied by x minus 2, and we just got another one, that is 2x squared plus 1. Okay, that is the factors for q. Remember, our original polynomial is px. Alright, px. Let me show it to you. Px, our original polynomial is px equal to, okay, 3x multiplied by qx. So the complete factorization of px is this one, that is px equal to, we have 3x, then multiply by qx, and qx is all this. So multiply by x plus 1, x minus 2, and 2x squared plus 1.